Hello friends, so welcome to this lecture 7 on integral calculus. What I'm going to be doing in this lecture is some questions based on standard integral formulas. So we have a set of 6 formulas here. So I'm going to teach you the application of these formulas. Okay, so we have done 6 lectures so far on integral calculus. In this lecture we are going to do formula based problems, and this is going to be one of the easiest lectures for you because all you have to do is learn these 6 formulas and the application of this would be so straightforward. Okay, and believe me, in CA foundation level, the difficulty level when it comes to application of these formulas is very elementary. Unlike those of you who have done in school, may have even done more complicated problems, but what we are going to do here is very elementary, just the basic application of these formulas. Okay, so look at these formulas now. You have integral dx by x square minus a square. Okay. See, up to lecture 6, what we have done is, we have done integration basic, of course, where we had added 3 functions and we integrated each of the 3 functions separately. We had also done integration by substitution, where you had product of 2 algebraic functions or division of 2 algebraic functions, or even a function like x bar x into 1 plus log x. Again, that was integration by substitution. Then in the subsequent lecture we had done integration by parts, again for functions which are product of 2 algebraic functions, or or even algebraic and exponential and so on, like x square into e power 3x was one of the complicated problems of parts. Then we did partial fractions integration, where we had division of 2 algebraic terms, linear by linear, or linear by quadratic, quadratic by a cubic, or a quadratic by or a linear by a quadratic, and these kind of problems also we had done. Okay, so now in standard integrals, what are the questions that will be covered under standard integrals? The problems that will be covered under standard integrals will be, look at the terms that I have written here, where you purely have integral dx by x square minus a square, integral dx by a square minus x square. So now you can ask me a question, integral dx by x square minus a square, can't we write it as x plus a into x minus a and then do it by partial fractions? Yes, you can very much do it by partial fractions, but all of you know that partial fractions take some time. So instead, if you have this formula, you can just apply and the sum will be over in a few seconds. Okay, so this is what we have in the first 2 formulas, x square minus a square and a square minus x square. In the third one, we have dx divided by root of x square plus a square, and in the fourth one we have root of x square minus a square in the division. Now the fifth and the sixth is without division. We have x square plus a square in the fifth one, and in this one we have x square minus a square. So what are the formulas? We have to just look at the similarity between these formulas. This formula here, the first one, x, when it is in the denominator, it is going to be log of x minus a divided by x plus a. And similarly, when the symbols are reversed, it will be log of course, 1 by 2a has to be there. Then log of a plus x divided by a minus x. Now, when we have a root in the denominator, it will be log of x plus root of x square plus a square. That term will come here. When it is minus, if the symbol changes, then it will be the same thing, but that term which is there in the denominator, you will put it here. Okay. Then next, the fifth one, which is not in the denominator, just in the numerator. In this kind of problem, what we will do is x by 2 root of x square plus a square plus a square by 2 plus log of, then it will repeat whatever we had in the third and the fourth. Third and the fourth is very similar to the fifth and the sixth. This log of is going to repeat in the third and the fourth one. Okay, but apart from that, the other terms that we are going to have is x by 2 into x square minus a square minus a square by 2 log of this whole term. Okay, So now that we have learned these formulas, let us see how to apply it. Okay, so look at question number 12. Look at question number 12. In question number 12, the question says, using method of partial fractions, the integration of f of x when f of x is equal to 1 by x square minus a square. What will be your answer? This is what the question is asking you. Now, please don't worry about the question mentioning partial fractions. You don't have to do it by partial fractions because there is an integral formula available and you are not going to work out. This is not a descriptive paper, it's a multiple choice paper. So this is the advantage with you. So what is the question? 1 by x square minus a square. So come to the formulas here. So the answer is straight away 1 by 2a log of x minus a divided by x plus a, which is nothing but option C. Okay. So first the x minus a will come, then the x plus a will come. Is it clear? Let us go to the next question. That is question number 22. Now look at this question. F of x is root of 1 plus x square. So where is the root? In the numerator. Where is the term? In the numerator. It is not in the denominator. Now we will integrate this. Let us write this question down. Question number 22. Integral root of 1 plus x square dx. This is the question. Now look at this question. I'm going to slightly rearrange the terms by writing it as root of x square plus 1 dx. Okay. Now after this, what we are going to do is look at this and compare it with number 5. In number 5, what are we doing? In number 5, we are having x square plus a square. So this 1 is nothing but your a square term. So a is nothing but 1. Okay, it could be plus or minus 1, but here we're just going to take it as x square plus 1. Now let us just use this formula. X by 2 root of x square plus 1 plus a square by 2 1 by 2. Okay, so I don't have space here, so I'm just going to write these terms close to one another. Plus 1 by 2, a square is 1, so 1 by 2 log of x plus root of x square plus a square plus c. Okay, so now what you have to remember is when you get a question on standard integrals, if you know the formula thoroughly, you have straight 1 mark into your pocket. Okay, so because see, the question just takes, if you remember the formula thoroughly, you don't even have to do this. You can straight go to the options and check which one of the options is matching. Okay, so look at this. So it's straight here, x by 2 root of 1 plus x square plus half log of x plus root of x square plus 1 plus k. So answer is option B. Okay, now let us go to question number 23. Question number 23, you have integral x square plus 1 divided by root of x square plus 2. The dx is missing here. We have written just the d, it's just a printing error. Whereas you see in this question the dx is available. It's just a printing error. The dx should have come here. Okay, so let me just write it here. Integral x square plus 1 divided by root of x square plus 2 dx. Now, if at all I have to say, there are only 3 problems in this exercise 8b on the standard integrals, and you saw 2 problems already. They were so straightforward. This is the 3rd problem. This is the only slightly complicated one. So let us see how to solve this. Okay. So now we have this term in the denominator. We have a 2 here, but whereas we have a 1 here. Had this number been 2, what would have happened? We would have been able to cancel this and this. Correct? Let me repeat. Had this been 2, we would have been able to cancel this term and this term. However, it is not 2. So what we can do is we can bring 2 here by making it as x square plus 1 is already there. Add a 1, right? Then it becomes 2. But whenever we add, we also subtract 1 divided by x square plus 2. Okay. Now let me further split this. Integral x square plus 2 divided by root of x square plus 2 minus this 1, you leave it as it is, dx divided by root of x square plus 2. Let me just repeat. This minus 1, where it went? This 1 and 1 I added and I have written it as 2 here. This minus 1 still remains here. Okay. I have not written because the impact of that is not there. And that minus we have put it outside here. Okay. So this is what we have. Now these two terms we can cancel comfortably and we can rewrite here as x square plus 2. Okay. And this is nothing but dx divided by x square plus 2. Now we have the formula for this as well as this. What is the formula for this? Look at this term. Whatever formula we have done here, the same thing is applicable here also. So let me just solve this part first. What is a and what is a square? A is nothing but root 2 because a square is 2. Okay, so now using this whatever formula we have used here, that is we have used formula number 5, x square plus a square formula. This formula I am going to use now. Okay, what does the formula say? The formula is nothing but x by 2. So let me write that, x by 2 root of x square plus a square. So x square plus 2 plus a square by 2. A square here is 2. 2 by 2. What is the formula? A square by 2. So what is a square? A square is 2 here. So 2 by 2 log of, open the bracket, x plus root of x square plus a square. X square plus a square is 2. Close the bracket. Is it clear? Now this 2 and 2 will get cancelled. So what I have done is I have just integrated this term. Now coming to the next term. This term, how we will integrate this is, come to formula number 3. Dx divided by root of x square plus a square. What you get is only this simple term. Okay. So dx divided by this root of x square plus a square is nothing but log of x square, log of x plus root of x square plus a square. Okay. So now let us integrate this term. Put the negative as it is. It will become log of x plus root of x square plus a square, which is 2 in this case. Close the bracket plus k. Now you will notice that this term and this term are same. So we are cancelling both the terms. So we are left with only x by 2 root of x square plus 2 plus k. This is our answer for question number 23. Now we saw how big these formulas were. But look at the number of steps in which the sum is getting solved. So if you learn the formulas thoroughly, practice it a couple of times at home, okay, then you'll be very comfortable in these kind of problems and straight 1 mark into your pocket. Okay, so let us match the answers. So one mistake in the options is option A matches, but here they have written it as x by root 2. Actually, it is not x by root 2, it is x by 2. The formula itself is not x by a. The formula is x by 2. So this is a mistake. It's a printing error. Otherwise, the answer is none of these. So you can just check question number 23. What is the answer given here? The answer is given as option A. But the problem in option A is we got 2 here, whereas the answer says root 2. Now, what is the formula for standard integral? This formula is x by 2. It has nothing to do with the A value. So, the answer is x by 2 only. Okay. So, here it should be only x by 2, not x by root 2. So, answer is option A, but of course, the correction has to come here. Okay. So, there's a printing error in your options. Otherwise, the answer is option A. So, students, please practice this adequately. See you all in the next lecture where I'll be doing definite integrals, and that will be the last lecture in integration. So please, as I say in every lecture, if you have any doubts, please post them as comments and I will address them in a separate video. Okay.